Hi, Calculus. We are on 2.5. This is log functions. So remember the end of the last one, we talked about why we couldn't solve that problem. We did not know how to get the exponent, which was a variable, out of the exponent. So in order to do that, we need logs, and that's what today is about. But before we get there, we have to learn how to write logs, how to graph logs, how they work, and then we'll worry about how to actually use them in our math. Okay, let's go. We should have 2.5 notes out. Okay, when you look here, first thing we're going to do is we're going to learn how to write them. Okay, then we are going to evaluate them or solve them. We're going to graph them. We're going to learn about properties. So how do they actually work? How do you add, subtract, multiply, and divide them? This change of base theorem is awesome. It's going to help them solve things a little bit quicker. You should use it actually a little bit on your ACT. We're going to solve log equations and exponential equations. All right, step one, how do we write them? Okay, so you are used to seeing this, a to the y equals 2x. So let's put this into numbers. Let's say this is 2x equals 8. All right, so you're used to a base, an exponent, and an answer, correct? When you do logs, the base is still there. It's log base a. So this 2 is here. So far you would write log. You would put the 2 underneath because that's the base. Okay, logs find exponents. So this time the x is what it equals. And the 8 is what it's of. So it's log base 2 of 8 equals x. This is the exponent. This is what your answer was over here. So let's try this. 3 squared equals 9. How do we write this as a log? We would do log base 3 of 9 equals my exponent. Okay, down here, log base 1/5, which is perfectly fine, of 25, because that's what it's of, equals the exponent, the -2. Okay, try yours. You're writing them both directions, so pause and give it a shot. So you should have said log base 10 of my answer, 100,000, equals 5. This is also known as a common log, so that base 10 is never written when you see it in an actual math. So they would go 1,000 or 100,000 equals 5 here, and then the 10 is assumed with a 10. That's the only time that happens, is just with base 10. Okay, how do you rewrite yours? Your base was 4. 2 the -3 is equal to the 1 over 64. I hope you did well. All right, now we want to evaluate logs, and there's a couple of ways to do these. First thing I would do is set this thing equal to x and rewrite it. So this means 4 to the x equals 64. We know 64 is 4 cubed. So now we have 4 to the x equals 4 cubed. Well, if that's true, x equals 3. Well, since x equals 3, then log base 64 has to equal 3, or 4 cubed equals 64. All right, try yours. Or another example, I'm sorry. This one here is kind of mean. I need to know, so we're going to let this equal x again. So 2 to the x power equals -8. There is no way to get 2 to a power to equal a negative number. So this is impossible, right? There's no solution. All right, because of this, it's actually undefined. Logs can never be negative on the inside. So if you have a negative answer, you can't do it. That's not possible. Something's wrong. Okay, try yours. Set it equal to x. So 5 to the x equals 125. You know 125 is 5 cubed. So that means log base 5 of 125 is equal to 3. All right, down here, now we're going to graph these things. And we're going to do this in a couple of steps. And once you get good at it, you don't have to do all this work. So we're going to graph the first one. This is just our exponential. We know this. So you go x, 2 to the x. I think we've even graphed this one before. 0, 1, 2. So we know 2 to the negative second power is 1/4. We know 2 to the negative first power is 1/2. 1, 2, and 4, right? So we go down here and we graph this. 1/4, 1/2, 1, 2, And we could keep doing 4 3/8. There is my 2 to the x, right? And that's my asymptote that I have. Now let's graph this guy. So let's start out here. X, this one's a little bit more difficult. Log base 2 of x. Well, let's just try this. -2, -1, 0, 1, 2. Well, if I plug in -2 here, we just talked about how this can't be negative in here. So this guy's undefined. Well, the same thing's going to be true here because because this is negative, so he's also undefined. So -1, -2 don't have an answer. All right, let's try 0. Let's go log base 2, 0. 2, what power equals 0? Oh, that doesn't make sense either. 2 to no power can equal 0, so this guy is also undefined. We're not doing so well here, right? Okay, let's try this one. Let's do log base 2 of 1 equals x. So this is 2 to the x equals 1. 2 to the x equals 1. Oh, that one we can do because we know that's 0. So now we got 1, 0. Life is much better. Okay, now let's try the next one. 2. So let's go log base 2 of 2 equals, well, that's just got to be 1, right? Because 2 to the first equals 2. Life is good. Let's not do 3. That looks hard. Let's do 4 because that's actually a power. So we know log base 2 of 4 equals x. Well, 2 to what power equals 4, and we know that's a 2. All right, let's graph these things. So I have nothing over here. I go to 0, so I have, this is my this. So now when I plug in 1, I got 0. When I plugged in 2, I got 1. When I plugged in 4, I got 2. And it just kept going. If you notice, look at here. Let's go here. These powers here are reciprocated over here, right? This point is 0, 1. This point is 1, 0. This point is 1, 2. This point is 2, 1. This point is 2, 4. This point is 4, 2. Do you remember what that was called when our points just flipped? I hope you do. They were inverses of each other, right? So if I have this one graphed right here already, I can just invert the point. So if this is 3, 8, the inverse is 8, 3. Because exponential functions are inverses of log functions. 2, 4 is 4, 2. 0, 1 is 1, 0. And I can graph in my thing. And also remember, your asymptotes change. This was the x-axis, so this one is now the y-axis. So if you graph one, you should be able to use your graph to graph the other. Okay, let's give it a shot. Or pause and try it, I should say. So you should have graphed this one. If you remember it, you don't have to do this. This is 1/9, 1/3, 1, 3, 9. Asymptote is here. So then you want -1, 1/3. I'm sorry, -2, 1/9, -1, 1/3, 1, 0, 1, 1, 3, 2, 9. There is my graph. Now to graph the log, it's the inverse of this. So we're just going to change the points. Instead of 2, 9, I'm going to graph 9, 2. Done. Instead of 1, 3, I'm going to graph 3, 1. Instead of 0, 1, I'm going to graph 1, 0. And I can continue. Instead of -2 or -1, 1/3, I'm going to graph 1/3, -1. -2, 1/9. And this is my inverse function or my log. So this is the log and this is the exponential. And if you look, they are symmetrical around the y equals x, just like our other inverse functions. Nothing new. All right, properties of logs. Let's see if you remember. Now remember, logs are exponents. So if I have like bases and I'm multiplying is what this is saying. So I have x squared times x cubed. What do you do with the exponents? You add. So you are adding the logs because they follow the rules of exponents. If I take x cubed divided by x squared, you subtract the exponents. So you are subtracting the logs when you're dividing. A power to a power, so x cubed squared, you are multiplying these two things. So I have to take this times this. I have to put it to the front and multiply. All right, you know that this one here is kind of fun. A to the first equals A. Anything to the first power is itself, the identity, right? So these actually cancel. And then every time I see it, I can just write 1. I know anything to the 0 power is 1. All right here, I know that this actually goes in front, and this here is 1, so I'm taking r times 1. So anytime I see this together, they will cancel, and I can just use the exponent. Okay, let's go here. I need to rewrite this into form of 1 log using all of these rules, and you have to do it in the correct order. The first thing is you can't have anything in front of the log, so the 4 needs to move up. So now we have log base 2 of 3 to the 4th plus log base 2 of x minus log base 2 of 7. It is very important at this point in time that all the logs are the same base. Later on, we'll learn how to work with those. So I know addition means multiplication. So I have to write this in 1 log. Now I have to follow my rules up here. So addition is multiplication. I am multiplying the 3/4 and the x, or 3 to the 4th. So I'm going to take 3 to the 4th times x. Minus means division, so I'm dividing by 7. And that's all there is to this. I would like you to rewrite it with the 3/4 is 81, since you can do that part, and that's the answer. Okay, here I want to pull it apart, so I want to make it more than 1 log. So the first thing I know is multiplication is addition. So we write this plus the log base 3 of x squared. Okay, so I've done that part, but now I cannot have an exponent, and I know a power to a power means multiply, so he must go down. So this is log base 3 of 7 plus 2 times the log base 3 of x, and that's all you can do. All right, try your 1, I'm sorry. So we got log base x. So x squared, divide. So I know that means subtract. So I have log base x of x squared minus log base x of y. This is my rule, remember? X to the x is 1 and the 2 goes in front. So this is really 2 times 1. So this whole thing is 2. If you recognize it, you can just cancel and go. Minus log base x of y. And that's done. I love logs, but they do take a little bit of work to practice. Change of base theorem. We use this when we can't actually calculate things. So we know this is a common log. We already talked about him. Log base 10 is the same as log 7. This here is on your calculator, so you have a log base 10 built in. Log base e is the same as natural log. So when you look at natural log, that is also on your calculator. So these two like bases are on your calculator already, and we're going to use them with our change of base theorem. The change of base theorem says I can take the log of any base of x divided by the log of any base of a, and this will give me my answer as long as these two bases are the same. That's a little confusing. So let's go down here. I want to calculate this. 80 is not a factor of 5, so I can't reduce it easily. So what we do is we do log of 80 over log of 5. Since they're both base 10, it follows my change of base theorem. You just type that in your calculator and you get the answer. You could have also done it. Remember, you have the natural log. If you do natural log of 80 divided by natural log of 5, it gives you the exact same answer because it is still the same base. Okay, try yours. So you should have done log of 50 divided by log of 3. That's a big 3. And that is equal to, I need a calculator. Give me a second here. I got 3.56. I hope you did well. You would have got the same result if you would have done natural log. All right, hang on, let's pause. Did I do my, okay, I should probably write that out. So it's the natural log, put it on here, natural log of 50 divided by the natural log of 3 gives you the exact same answer. It does not matter which base you use, which is true down here too. I could use the natural log of 80 over the natural log of 5 and get 2.7, or we could do the log of 80 over the log of 5, and you get the same answer. In your homework, it's going to ask you to say, hey, use the natural log or use the log. I really don't care which one you use, as long as you can get to the answer. It just wants you to realize that both of them work. So it's not important. Okay, solving logs equations. Some of them are easier than others. So when we look here, we have exponential form and then solve. So if I can rewrite this without the log, we are going to do so. So we're going to write this x cubed equals 8 over 27. Well, since x is in the denominator, we can solve this fairly easily because we're just going to take the cube root of everybody. And we get 2/3. And we're done. All right? Try this one. So first you should have rewritten. So this is 4 to the 5 has power equals x. Well, that means the square root of 4, which is 2 to the 5th, which is 32 equals x. I hope you did well. Okay, well, let's look at this dude. Now we're actually going to do some fun stuff here. So we got x minus log base 2 of x minus 1. There's no log over here, so it's not quite as easy as some of the other ones. So I have to rewrite this first, and they're both log 2, which is nice. We know subtraction means division. So we're going to do log base 2 of x divided by x minus 1 equals 1. Now I can rewrite it. So that's 2 to the first equals x over x minus 1. And now we can solve. So let's common denominator. So we got 2 times x minus 1 equals x. 2x minus 2 equals x. Subtract your x over. So minus 2 equals negative x, so x equals 2. You should always check. Plug it back in. 2 and 2, and when you plug that in, it is true. We are good. Okay, pause and try yours. All right, this time we had addition, which means you had to multiply. So you have log base 2, there we go, of x times x plus 2 equals 3. Rewrite, so 2 cubed equals x times x plus 2. Let's do our distribution. 8, x squared plus 2x, subtract the 8 over, x squared plus 2x, minus 8, factors of 8 that give us 2, are x plus 4, x minus 2. So now I get x equals negative 4 or x equals 2. We have to check. If I plug the negative 4 in, I have a negative log. And we learned earlier, that's bad. So negative 4 does not work. It doesn't mean it won't always. Sometimes when you plug them in here, there's still positive numbers, so you must check. And you plug in the 2 and it's good. So x equals 2 is the final solution. Okay, we need to solve this for x. So the first thing we do is we rewrite this because I need to get this x out of the denominator. So you can rewrite it like this, which is fine, and then solve it for x. So we know this is, oh, I can't solve for x. It puts me back where I am, right? But when you look at this, our change of base theorem helps us. So that's log base 5 divided by, log of 5 divided by log of 3. Type it in your calculator and you get your answer. Let's see if I got that done. And it's 1.46. Okay, the other way to do this is to take the log of both sides of the equation. Okay, when you do that, then the x goes down in front using our rules. So now we have x log 3 equals log 5, and then you divide by log 3. And we are to the exact same place, and that's why our change of base formula actually works. Kind of cool, right? Okay, let's do this one. Not quite as nice. No like bases, just not a whole lot I can do. So we have to take the log of both sides this time. There's no option since the x is here and here. Next, we're going to take the 2x in front. Be careful here. Log base of 3 equals, now we are bringing x minus 1 in front, in parentheses, log of 4. Okay, we're both base 10, so we're good there. I have to get this x by itself, or together, and I can't do that because he's in these parentheses, so I have to distribute this log through. So now we got 2x log 3 equals x log 4 minus, I could just put 1, but that's okay, log 4. All right, I need the x's on the same side of the equation. I know it looks ugly, but that's what we have to do. So now we got 2x log 3 minus x log 4 equals minus log 4. Okay, they both have an x in common, so I can factor it out. So this is 2 log 3 minus log 4 equals the negative log 4. Now to get x by itself, we divide by all that ugly stuff. So 2 log 3 minus log 4 is what we're dividing by. 2 log 3 minus log 4. Type that all in your calculator, and you get x equals 1.709. Ugly, I agree, but it is not anything different. You always put the x's on the same side of the equation. You factor out what they have in common, and you divide. Nothing different, just a little more complicated. So just watch your negatives and be careful. Okay, this works the same way, except now it's natural logs. So the first thing we're going to do is divide by the 5, because we need the e by itself. So 9 divided by 5 is 1.18. Okay, now to get rid of an e, remember the opposite of an e is the natural log. So you take the natural log of both sides, like so. Once you do this, these cancel, and we get 0.01x, and the natural log of 1.08, natural log of 1. This is just 1.8. I wrote that wrong, I'm sorry. 1.8, there we go. That looks much better. So the natural log of 1.8 is 0.58779 divided by your 0.01, and x is equal to 58, and we'll round to 2 decimals. Just be careful with natural log and log. Okay, try yours. Okay, when you look at yours, there's no e, so we have to take the log of both sides. So you do the log of 2 to the x plus 1 equals the log 3 of x. Now the x plus 1 goes in the front. Put him in parentheses so you don't mess up. Equals log, put the x in the front. 3. Okay, I have to get the x's together, which means I have to clear these parentheses. So x log 2 plus log 2 equals x log 3. Okay, let's subtract this over to get the x's to the same side. So log base 2 equals x log 3 minus x log 2. Factor out your x's now. Log 3 minus log 2 equals your log 2. I'm out of room, so I'm going to move up. And then you divide. So you have log 2 divided by log 3 minus log 2 equals x. Type that in your calculator. And you should get 1.71. All right, I hope you did well on that. Remember to take your time and just walk through that. You might want to listen to that one again. Okay, here we go. Doubling an investment. All right, so how long, whoa, I need an S. Does it take, you go fix that, money to double if invested at 5% interest rate? So if P is my initial, then A is 2P because I need to double my initial amount. Well, that means when you divide by P on both sides, they're just gone. So we get 2 equals 1 plus R to the T power. Okay, we're doing this because it wasn't compounded. There's no N, so this N is actually 1 is what's going on here. That's why this simplified so far. I know 0.05 is our interest rate is 0.05, and I'm going to solve for T. So now we plug the 0.05 in here, and we get this. Well, to get T, he's in the exponent, so I have to use logs again. So we go log of 2 equals log of 1.05 to the T power. I know this T is going to move to the front. So now we have log of 2 equals T times log of 1.05. Just divide by your log of 1.05. And the time it takes for money to double with 5% interest rate is, my calculator back, 14.2 years. Okay, try yours with 8%. Okay, so the only thing that changed in your formula was the 5 to an 8. So you still have T equals 1 plus 0.08 to the T power. So T equals 1.08 T, log both sides. I'm going to bring my T down right away just because I am out of room. Divide by your log of 1.08. And you should got T to equal 9 years. A little bit better. 14 is a long time. All right, good luck on your homework. Let me know if you have any questions.